Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our second lesson on a given Form 2 mathematics topic called linear motion. So we are looking at our example number 2, which is also a past cases question done in 2006, paper 1, question number 20. So example 2 reads that a bus left Mombasa and traveled towards Nairobi at an average speed of 60 kilometers per hour. So the first thing we're going to do is to obtain a simple sketch for the information that we are given. So we have two towns. One is Mombasa, then the other town is actually Nairobi. So we are told that a bus left Mombasa and traveled towards Nairobi. So we have a bus which is moving from Mombasa towards Nairobi at an average speed of 60 kilometers per hour. Then we are also told that after 2.5 hours, a car left Mombasa and traveled along the same road at an average speed of 100 kilometers per hour, which means that our car is also moving from Mombasa towards Nairobi. So this is our car, but it is starting its journey after 2.5 hours. Then we are told that the speed of the car is 100 kilometers per hour. Then, if the distance between Mombasa and Nairobi is 500 kilometers, so the total distance here is 500 kilometers, determine part A of the question, the distance of the bus from Nairobi when the car took off. The distance of the bus from Nairobi when the car took off. So, if we want to find the distance of the bus from Nairobi when the car took off, we are first of all going to find the distance of the bus from Mombasa, because the bus was coming from Mombasa when the car took off, so that when we subtract it from 500, we'll find the distance that is remaining to Nairobi. So we'll first of all start by finding the distance covered by the bus from Mombasa, because the starting point was Mombasa. When the car took off, will be given by, remember distance is given by speed multiplied by time, the speed multiplied by time. So because we are talking of the distance covered by the bus, we are going to use the speed of the bus. So the speed of the bus was 60 kilometers per hour multiplied by the time that had been traveled by the bus before the car started its journey was 2.5 hours. Therefore, the distance covered by the bus from Mombasa in 2.5 hours will be, so I'm going to use the time of 2.5 hours, because this is the time that the bus had already traveled before the car actually took off. So if you take 60 by 2.5, you are going to get 150 kilometers. Therefore, this is the distance that has been covered by the bus before the car takes off. So it has already covered 150 kilometers, but this one is from Mombasa. The question wants the distance of the bus from Nairobi. So if this is the distance from Mombasa, it means the remaining distance here will be the one from Nairobi. Therefore, you'll take the total distance, then you subtract the distance from Mombasa. Therefore, the distance of the bus from Nairobi, Nairobi, when the car took off, will be given by the total distance, which is 500 kilometers. Then you subtract the distance that it has covered from Mombasa, so that we remain with the one from Nairobi. So this will be 500 then minus 150, which is going to give us 350. So 350 kilometers. So this is the distance that that is the distance of the bus from Nairobi when the car takes off. Then we can move to part B of the question, that is part A, Roman 2. So in Roman 2, we are asked to find the distance of the car, that is the distance the car traveled to catch up with the bus, which means these two actually caught up somewhere. So therefore let me obtain another sketch for the same movement. So here we had the bus, which was moving at a speed of this is our bus, was moving at a speed of 60 kilometers per hour. Then we had the car, here, which started after 2.5 hours. Then its speed was 100 kilometers per hour. Of course, this is Mombasa. So we are asked the distance the car traveled to catch up with the bus. So we are going to assume that these two they caught up at this particular point. So because we don't know that distance, I'm going to give it a letter such as X. So I will let that distance to be X. That is from Mombasa to the point where the car is going to overtake the bus. I will let that distance to be X kilometers. Therefore, I'll say let the distance, let the distance the car traveled, let the distance the car traveled to catch up with the bus, with the bus, be X kilometers. So I'll let that distance to be X kilometers. Remember, the car is catching up with the bus because, remember, the bus is moving at a slower speed of 60, whereas the car is moving at 100 kilometers per hour. So it means, because the car is moving at a higher speed, it's likely to catch up with the bus at some time. So we are letting that distance that the car will cover from Mombasa to when it catches up with the bus to be X. Therefore, I'm going to find the equation for the time because we know that at the point where the two are catching up, the clocks of the drivers of those particular vehicles must be reading equal time. Therefore, we can talk of time taken. We can start with maybe the bus. Time taken by the bus to arrive. Time taken by the bus to arrive at the meeting point. Will be given by, remember, time is given by distance divided by speed. Time is distance over speed. Therefore, the distance that the bus covered from Mombasa to the meeting point will just be X kilometers. So it will be X, then divided by it. The speed of the bus was actually 60 kilometers per hour. Then you also find the equation for the time taken. So you also find an equation for the time taken by the car to arrive at the meeting point, So remember, both vehicles started from Mombasa. So it means the time taken by the car to arrive at the meeting point will actually be the 2.5 hours because it started 2.5 hours later. So it will be the 2.5 hours that it started late. Then you add the time taken on the road. So time taken by the car on the road is a distance over speed. The distance, because they are both moving from Mombasa to the meeting point, it simply means they are going to cover the same distance with the bus. Therefore, a time of the car to arrive at the meeting point, time is distance over speed. So the distance is still X kilometers because they are starting from the same point, Mombasa, then they are catching up at the same point, moving on the same road. It means the distance will actually be the same. So it will also be X. So time is distance over speed. Then the speed of the car was actually 100 kilometers per hour. Then there is one fact that we know, that at that particular meeting point, the clocks of those two drivers, that is the driver of the car and that of the bus, should be reading equal time. So we are going to say that at the overtaking point, the equation of time for the bus must be equal to the equation of the time for the car, because remember, at the meeting point their clocks are reading equal time. So at the overtaking point, the equation for the bus to the time taken by the bus to arrive at the meeting point was X divided by 60. This equation must be equal to the equation for the time taken by the car to arrive at the meeting point, which is 2.5 hours. Then you add the time taken on the road, which is x over 100. Therefore, this can be rewritten as x over 60 is equals to 2.5 is the same as, into fraction, is the same as saying 25 then divided by 10. 25 divided by 10, which is actually going to give us, if you simplify, you'll get 5 over 2, then of course plus x over 100. So the LCM here is actually we can talk of 300. Yeah, 300. So I'm going to multiply through by the LCM. So I multiply through by 300. I also multiply this by 300. This one also by 300. So this is going to give us, if you take 300 divided by 60, you are going to get 5. Therefore, this will be 5x is equals to, if you take 0 and 0 will cancel out. So if you take 25 multiplied by 30, you are going to get 750. So this will be 750. Then plus 2 zeros will cancel out. So this one will remain to be 3x. If I collect the like terms, I'm going to have 5x then minus 3x being equal to 750. Therefore, it means that 2x will actually be equal to 750. Therefore, the value of x will be equal to 750 then divided by 2. Therefore, x will be equal to 750 divided by 2. You are going to get 375. But what was x representing? X was representing the distance the car traveled to catch up with the bus. Therefore, it was distance in kilometers. Therefore, it means our x is actually 375 kilometers. So remember, we had already defined x here. So therefore, the distance the car traveled to catch up with the bus was actually 375 kilometers. 375 kilometers. So from this particular diagram, we can actually indicate the distances that we have gotten here. So let me just indicate on this diagram. So it means if they caught up at this particular point here, then the distance from Mombasa to the meeting point is 375 kilometers. So this distance is 375 kilometers. Then remember, the total distance was 500 kilometers. So it means the remaining distance from the meeting point to Mombasa will be 500 kilometers, then minus that is the 375. But for Roman A, Roman 2, the answer will be 375 kilometers. Then part B of the question, we are told that immediately the car caught up with the bus, the car stopped for 25 minutes. Then find the new average speed at which the car traveled in order to reach Nairobi at the same time as the bus. So let me create some working space here. Let me create some working space. So part C of that is part B of the question, we are told that immediately the car caught up with the bus, the car stopped for 25 minutes. So actually I can obtain another rough diagram here. That is for the two scenarios. So this is Mombasa, then of course this is Nairobi. Then these two they caught up after 375 kilometers. Suppose this is the point where the two actually met. Then remember, we had the car here traveling at a speed of 100 kilometers per hour. Then we also had the bus which was traveling at 60 kilometers per hour. So this is the meeting point. So we are told that immediately the car caught up with the bus, the car stopped for 25 minutes. So we have the car here which is stopping for 25 minutes. Then find the new average speed at which the car traveled in order to reach Nairobi at the same time as the bus, which means the car had a new average speed, which I'm going to let it to be x kilometers per hour. Then we are not told that the speed of the bus changed, which means we are assuming that from the meeting point up to Nairobi, the bus will still travel at its initial speed, which was 60 kilometers per hour. But due to the fact that we are asked to find the new speed of the car, it means that the speed of the car actually changed. Then you are told that find the new average speed at which the car traveled in order to reach Nairobi at the same time as the bus. So we are going to find the equation for the time taken by the bus to arrive in Nairobi from the meeting point from their meeting point will be given by, so remember time is given by distance divided by speed. So we are going to use the distance from the meeting point to Nairobi. So remember the remaining distance here will be 500 minus 375. So if I take 500, then I subtract 375, I'm going to get the remaining distance will be 500 minus 375. The remaining distance is 125 kilometers. So the remaining distance here, this distance is 125 kilometers. So that is the distance remaining to be traveled from the meeting point actually to Nairobi. Therefore, we are going to have the time taken by the bus to arrive in Nairobi from the meeting point will be equal to the remaining distance to Nairobi is 125 kilometers, then divided by the speed of the bus did not change, which was still 60 kilometers per hour. So this is the time taken by the bus from the meeting point to Nairobi. Then you are told find the new average speed at which the car traveled in order to reach Nairobi at the same time as the bus. So remember at the meeting point their clocks are reading equal time. Therefore we are also going to find an equation for the time taken by the car now, the time taken by the car to arrive at Nairobi, Nairobi from the meeting point, So this particular time will be given by, so remember the car stopped for 25 minutes. Therefore the time that it takes from the when the two caught up to Nairobi will be 25 minutes plus the time taken by the car on the road. So this will be 25 minutes. If you convert 25 minutes into hours, remember 60 minutes is equals to 1 hour. Therefore 25 minutes into hours will be 25 over 60. Then I'm going to add the time taken by the car from the meeting point to Nairobi. Time is distance over speed. The distance remaining from the when they caught up to Nairobi is actually 125 kilometers. Then divided by the new speed of the car. So we don't know the new speed of the car. That's why I'm indicating it as the X. Then from this particular point, we are simply going to equate the two equations because we are told if at which we are told to find the new average speed at which the car traveled in order to reach Nairobi at the same time, which means these two equations for the time from the meeting point, this equation and this equation should actually be equal because we have already catered for the 25 minutes extra that the car traveled. So if they are to reach at Nairobi at the same time, then it means this equation must be equal to this other equation. Therefore, for them to reach at Nairobi, the time taken by the bus, which is 125 divided by 60, must be equal to the time taken by the car, which is it took 25 extra minutes. So 25 divided by 60. Then we are going to add the time that it took on the road. Time is distance over speed. The remaining distance is 125 kilometers. Then the new speed of the car, we don't know it. That is why I'm calling it to be X. So X is our new speed of the car. So the LCM in this case will be 60x, so I'm going to multiply through by the LCM. So I multiply this one by 60x, which is the LCM, also this one by 60x, the LCM, also this one by 60x, because I want to do away with fractions. So 60 and 60 will cancel out, 60 and 60 will also cancel out, then x and x will cancel out. So we are going to remain with 125 x being equal to 25 x, then plus 125 by 60, 125 multiplied by 60, I'm going to get that is 125 by 60. So remember, this is 25x. 125 by 60, I'm going to get 7,500. 7,500. So if I collect the like terms, I'm going to have 125x minus 25x, which should give me 7,500. So 125 minus 25, I'm going to remain with 100. So 100x is equals to 7,500. Therefore, the value of x will be 7,500 divided by 100, which is going to give us 75, because the two zeros will cancel out. But remember, 75 is representing the new speed of the car. Therefore, this will be 75 kilometers per hour. Therefore, we are going to conclude and say that the new speed of the car, will be equal to 75 kilometers per hour. So we've come to the end of our class today. Thank you very much for accompanying me until the end of this particular lesson. So we'll be looking at further examples in our next classes. Thank you very much for taking me to the end of this lesson. So until next time, this is Kind Tuition Academy. Thank you very much.